This lesson's on symmetry. We're going to talk about three different types of symmetry today. The first of which is line symmetry, which is what most commonly is referred to when we're talking about symmetry. Line symmetry is whenever a figure can be mapped to itself by reflecting it with a line. In this case, if we drew a line that went straight up and down through this triangle, notice that both sides are the same. So it has a line of symmetry. This line itself would be a line of symmetry. Figures can have more than one line of symmetry, or they can have one and still be considered symmetric. The next type of symmetry is called point symmetry. So point symmetry means that you could put a point in the middle and rotate this 180 degrees and it still look the same. Basically, point symmetry, if you turn it upside down, it still is the same figure. The last type of symmetry we're going to talk about is rotational symmetry. It still is focused around a center point, but we need to figure out how that ends up looking. So if we actually look at these ones with rotational symmetry, we can see a pattern. And the pattern repeats itself around the figure. You just have to figure out how many times it repeats itself and if it's the same all the way through. So notice in this one, this looking like sun, we've got 8 different triangles on the outside, right? And they're all equally spaced. With rotational symmetry, we have something that is called an order, which basically means how many times does it repeat. So in this case, we have an order which is 8 because it repeats 8 times. Now we also can get an angle from this. So the angle from this is fairly simple. Since the entire or a full circle is 360 degrees, what we end up doing is we take the value of 360 and divide it by the order, in this case 8, and end up getting our rotational symmetry. So in this case, our angle of rotation, which is 45 degrees in this case. Now, one thing to note on these, if you have a figure that has rotational symmetry, if that rotational symmetry is an even number, it will also have point symmetry. Because if you can do it an even number of times, that means halfway through that, it still is going to have symmetry. So if again the order is an even number, it has point symmetry as well. Now, for the next part, we're going to look at these figures and determine if it has line, point, and or rotational symmetry, and we're going to check all of it that applies. So there could be more than one answer choice for each of these problems. On the first one, we've got this hexagon. Right. So, does it have line symmetry? Yeah. In fact, it could have, depending on if you want to interpret this as a regular hexagon or not, it could have more than others. Right? Does it have point symmetry? Well, if I turn it upside down, is it the same? Yes. Does it have rotational symmetry? Well, if it has point symmetry, it's going to have rotational symmetry as well. But this one, yes, it does have rotational symmetry. And if it was regular, this would be an order of 6. Okay, number 2, does it have line symmetry? Well, if we draw a line straight through the middle, yeah, it would end up being reflected. So yes, it does have line symmetry. Does it have point symmetry? The top is not the same as the bottom, so no, it does not have point symmetry. But rotational symmetry, does it repeat? Well, yeah, it repeats 3 times, so it does have rotational symmetry. Number 3, does it have line symmetry? Right. In this case, I can draw a line through the middle. It wouldn't be the same on the other one. I could even draw a line that's slightly diagonal, matching up with the sides over here. But if I reflect this over, right, notice that it's becoming perpendicular here to this line. So it would need to have its point on this side. So it does not work through that way. So, or if I even did a line flat this way, it works the same way. Again, this point would have to be matching up to something there. So no, there is not line symmetry on this one. The point symmetry. Well, if I rotate 180 degrees, is it the same? Yeah. Okay. And again, since it repeats twice, it is rotational symmetry as well. So let's look at number 4. So number 4 here, we got this right triangle. Right? Does it have line symmetry? No, none of these lines are the same. So no line symmetry. Is it the same upside down? No, no point symmetry then. Is there any repeating or pattern? Nope. No rotational. So the answer is none. All right, number 5. Does it have line symmetry? Yes. Does it have point symmetry? Turn it upside down? No. Does it have rotational? Yeah, it repeats 5 times, so rotational symmetry. All right, number 6. Does it have line symmetry? Did it line this way? Maybe? No. Again, because these don't end up working through it. So no line symmetry. Point symmetry, 180 degrees. Yeah, it matches up. So, yeah. Again, if it can turn 180 degrees, it can still turn 360 degrees and still get the same. Number 7, line symmetry. Draw a line straight. Point, upside down. Nope. Rotational. Nope, no repeating that way. So only line symmetry. Number 7, does it have line symmetry? No. Does it have point symmetry? No. Does it have rotational? No. So none. All right, number 9. Does it have line symmetry? No. Does it have point symmetry? If I turn this upside down, is it the same? All right. Yeah. The rotational? Yeah, it repeats 4 times. And notice it repeats 4 times. It's an even number. So again, anytime it's an even number on repetition, it is also point. Moving on to number 10. Does it have a line symmetry? We can draw a line straight through, or we can draw a line horizontal. Either of these ones gives us equal parts. The point symmetry, yeah, turn it 180 degrees, still looks the same, which also makes it rotational. Number 11, line symmetry, no. Point, no. Rotational, no. So none. 12, line symmetry, yeah, go straight up and down, you get line. Point, no. Rotational, no. 13, line symmetry, yeah, anytime going through these, like that one, this one, or this one here, all 3 of those are lines of symmetry. Point symmetry, turn it upside down, it's not the same. Rotational, repeats 3 times, so yeah. 14, line symmetry, nope, no line does it. Point, turn it upside down, yep. Rotational, does it repeats twice, yep. 15, line symmetry, yeah. Lines up and down, and then the diagonals, yeah. 4 different lines of symmetry. Point symmetry, yeah. Turn it upside down, still the same. Rotational, repeats 4 times, there we go. 16, playing card, line symmetry. All right, if it went sideways, no, they're not the same. It went up, down, again, it was flipped on one side, so no, not line symmetry. Point symmetry, rotate 180 degrees. There we go, that one actually does work. Again, since I can do 180 degrees, that is still rotational symmetry as well. 17. Line symmetry, no. Point symmetry, no. Rotational symmetry, no. So none. 18. Line symmetry, yeah. Horizontal line. Is it the same if you turn it upside down? Not flip it upside down, but turn it upside down. No. And again, if that's not the same with that, it's not rotational either. 19. Line symmetry. Those arrows mess up the line symmetry on this, so not line symmetry. Point symmetry. Again, is not going to be the same upside down as it is how it is right side up. Okay. And then rotational symmetry repeats 3 times, so yeah. And lastly, the snowflake. Yeah, there's line symmetry.